Welcome to Physics Videos. Today's topic is experimental design. The first part of designing an experiment is choosing variables. This can be done by listing things that you can change about how something occurs, and listing things you can measure about what is happening. The first list contains potential independent variables. The second list is possible dependent variables. These are things that might change because of what I did. I measure these changes during the experiment. Once I choose an independent variable, all other possible IVs should be kept constant. Once you have chosen your variables, you can write a research question. The simplest version is to ask, what is the effect of my IV on my DV? Fill in the name of the variables. The last part of design is to write a procedure to follow to collect your data. This can't be done until after you have collected data. Right now you don't know what obstacles you will encounter or how you will solve those problems. After you've done it, you can write a good set of instructions. As you collect data and plan what you want to do, you should plan to have 5 different values for your independent variable. This is called 5 levels of IV. You should repeat each level of your IV 3 times. That means measure the corresponding value of the DV for 3 trials. Data should be organized in a neat, label table. Here is an example of a generic data table. Every data table should have a title. The easiest title is to simply name your variables. The first column in the table is for your IV. At the top of the column, write the name of the variable and what unit you will use to measure it. For example, your IV might be height measured in centimeters. The heading for your DV should span 4 columns, as shown here. First, write the name of the DV and its unit of measure. Then add labels for each trial and an average column. The body of your data table should contain only values for the variables. Do not write the unit of measure here. You already have it with the column label. Now that you have your data, you can write a procedure for how to collect it. The procedure you write is a numbered list of instructions. It tells how to collect your data and should be specific to your experiment. The procedure should state the values for all constants in the experiment. It should also state the value for all of the levels of your IV. This means write the values, don't write choose 5 values. Finally, the procedure should explain how to repeat each measurement and how many times it should be repeated. The next step in an experiment is to process your data. At a minimum, this means making a graph. Since you have numerical data, there should be no bar graphs. You will plot points on your graph. This is called a scatter plot. Then you will try to determine if there is a trend in the data. Here is a generic graph that shows how it should be labeled and titled. Every graph has a title. Like the data table, the easiest way is to list your variables. The IV always goes on the horizontal, or X, axis. Label the axis with the name of the IV and the unit of measure. The DV always goes on the vertical, or Y, axis. It should also be labeled with the name of the DV and the unit of measure. When choosing the values for the lines on your graph, remember that they must be equally spaced. The X and Y axis do not have to have the same interval. Now you should plot your points on the graph. Once the points are plotted, we want to look for a pattern in the data. These points look like they form a straight line. It's not perfect, but it looks straight. So, let's add a line to the graph. Notice that this is not a dot-to-dot line, but it shows the overall pattern of the data. This line is called the trend line. The trend line doesn't have to touch any of the points. It shows us that when the IV is increased, the DV will also increase. This is called a direct relationship. The last step in experimenting is to explain what we have learned. This part of the experiment is called the conclusion. The conclusion has 3 parts. The first part is where we state how our variables are related. In this example we would say that the dV is directly related to the IV. We might also want to include 2 points from the graph to show that when the IV value increases, the dV value also increases. The second part of the conclusion is where we evaluate our procedure to identify where we might have introduced error or uncertainty in our measurements. Not only do we identify the error, but we also want to know what type of error it was, random or systematic. The last part of the conclusion tries to identify ways to reduce the error in our measurements. That's it for experimental design. I hope this video was useful and helped you with your experiment report.